Okay, we're done with this problem. Let's go to our next problem. Rods and dots. A uniform thin rod of length L and mass M, pivoted at one end, as shown at the right, is held horizontal and then released from it. So meron kang, parang ito, pinababa kang gano'n. Yun lang yung nangyari. So, first, what is the angular velocity of the rod when it reaches the vertical position? So, pagbagsak niya, ano yung angular velocity nitong rod na to nang bumagsak siya? And then, the second one is find an expression for the angular velocity of the rod as a function of the angle relative to the vertical given by theta. So, given dyan yung theta. Sige. I'll just show you the solution to this problem. Okay? Okay, again, you have a uniform thin rod of length L and mass M that's pivoted at one end as shown. So the first one is what is the angular velocity of the rod when it reaches the vertical position? So parang komplikado niyan, di ba? By the way, I at edge is 1/3 ml squared. Edge dito means that the rod, the axis of rotation of that rod is at the edge, not at the center of mass. Okay? Hindi sa center of mass. Iba yung magiging expression mo kung nasa center of mass yung moment of inertia. But for the meantime, ibigay ko muna yan. Okay, sige. So first, what is the angular velocity of the rod when it reaches the vertical position? Para natin hahanapin yan. Pansinin mo, in center of mass, bumaba, di ba? So therefore, meron kang, so pwede mong isipin to na may state, initial and final states ka. If this is my state 1, and this is my state 2, then the initial state, so my initial state, state 1 is that the rod is at rest, and the rod reaches the vertical position with some omega final. Okay, now let us assume that in our coordinate system, let us say y equals 0 at, set y equals 0 at the initial position. Okay? So, mangyayari, this is what I will mean by y equals 0. Medyo lakihan ko yung drawing ko, ha? Sige, let me redraw it. So, meron ako ditong rod, initially. Tapos, meron akong final position ng rod, which is parang ganyan. Tapos, this is what I will set as y, my y equals 0. And this is the position of the initial position of the center of mass. This is the final position of the center of mass. Okay? Ang assumption natin dito, ang rod ay uniform. Kasi pag hindi yan uniform, medyo kailangan mag-compute. Okay? Sige. Now, what we will do, so remember, there is a change in the position of the center of mass. Since there is a change in the configuration, use conservation of mechanical energy. We use the conservation of mechanical energy. And from there, what we will be doing is simply 1/2, so you have E1 equals E2, and this is simply 1/2 capital M VCM squared plus 1/2 I omega squared plus mg YCM on the initial position is simply 1/2, so this is all initial, 1 yan, 1/2 capital M VCM2 squared plus, ang haba ng expressions, plus, ay, gulo, sorry, plus, sige, huwag na ilipat, plus 1/2 I omega 2 squared plus mg YCM, YCM 2, ang pangit, sorry, YCM 2, yan. So yan. Now, meron bang linear velocity dito? Nag-translate ba yung center of mass? As in, dumulas-dulas ba siya?
Di po.
Hindi, di ba? Hindi siya dumulas-dulas. Hindi siya dumulas-dulas. Therefore, what we expect is both initially and finally, there's no translational kinetic energy. Diba? Kasi ang velocity niya, magkaka-tangential velocity yan, but that's due to rotation. Hindi siya translational velocity. Okay? Mayroong translational velocity kasi magkaka-velocity yan, no? Yan, tsaka yan. Pero depende yun sa angular velocity nung rigid body. Yung velocity niya nakabase lang sa angular velocity. So, okay. Now, what is the initial angular rotational kinetic energy of the rod? Ano yun? Ano lang yan? Gumagalaw ba yung rod initially? Hindi, di ba? Therefore, this is 0. And also, we set y equals 0 at the top. Therefore, this is also 0. Okay? So yon. Now, so we have, simplifying our expressions, you have 0 equals what? Let's say some the final angular velocity is omega f. So we have 1 of I omega f squared plus mg times what is the height now of the center of mass at the final position? Ano ngayon yan? Ano ngayon yan? So if the length of the rigid body, or if the length of the rod is capital L, what is this height here? Ano yan?
1
The
of L.
Yes, it's L over 2 because you are assuming that the rod is uniform. So this should be L over 2. In fact, the position now is should be negative L over 2. Negative dapat yan kasi nasa baba siya nung sinat natin ng y equals 0. Okay? And hence, okay, but I know that this is simply this 1/3 capital ml squared. Isulat ko na, so ilipat ko na sa kabila tong ano na to. Ito pala yung ilipat ko sa kabila. So this is just equal to mg L over 2. So ang mangyayari, the 1 half will cancel. The m will cancel, so it's independent of the mass of the object. The L, I have an L here. So this gives me kulang ito, omega f squared. So this is 1/3 L omega f squared equals g. And therefore omega f is simply square root of 3g over L. That is the final angular velocity of the particle. Okay, nakuha? Nakuha to?
Yes po.
Okay, so ganun lang yung mangyayari. So essentially, you have a conservation of mechanical energy in that system. Sige. So for letter B, you will use the same equation, use conservation of mechanical energy, except that the final position, hindi na ganun kasimple yung final position ko. So use again, conservation of mechanical energy. So use com. And so the left-hand side, because this is just the same initial position, so pwede kong i-drawing ulit yan. So I have something like this. Tapos meron akong some final angular velocity dito. Tapos yung angle na to ay theta. So this is some theta. Therefore, what can we say about, and if we assume that this is what my y equals 0, what can we say about the initial angular velocity? Or I should say, what can you say about the initial kinetic energy of the system? Ano lang yan? Same as in the previous sub-part of this problem, 0 lang yung magiging initial kinetic energy. So this is just 0 equals what? Ano lang yan? So I have 1/2 m VCm squared plus 1/2 I omega squared, I'll just write it as omega, plus mg y cm. Again, this is 0 because there is no translational velocity there. The velocity is just due to the rotational velocity or the angular velocity. So this is simply 1/2 I times omega squared, or sige, sulat ko na muna 1/2 I omega squared yan, plus mg times what's ycm now? So if this is initially the x, the center of mass, ito yung some position ng center of mass at some final angle theta. Ano ngayon yan? Ano ngayon yung magiging height niya? What is his ycm? Ano yan? In terms of the given quantities, what's ycm? Ano yan? So para kang may triangle, di ba? So if this is my triangle, this is my theta, this is my L over 2. Ano tong angle? Ano tong side? Ano tong height na to? What is this h here? Ano yan?
Y cosine theta.
This is L over 2 times cosine theta. But since nasa ilalim siya, we write this as negative L over 2 cosine theta. Tama? Tama?
Yes.
Okay. And thus, when you transfer this again to the other side of the equation, I have an mg 1/2 L cosine theta equals, so this implies 0. So this implies mgl cosine theta is simply 1/2 times 1/3 ml squared multiplied by omega squared. So the 1/2 again will cancel. The L, isang L na lang yan. Yung M magka-cancel. And therefore, what you get here is omega is the square root of, is just, 3g over L cosine theta raised to 1/2. That's the final answer. That's our omega as a function of theta. Okay? Nakuha? Questions?
None so
Questions?
far.
Wala. Okay. Now, the point here is this. Papansinin nyo, at theta equals 90 degrees, ano yung omega mo? What's cosine of 90 degrees? 0, di ba? Therefore, omega equals 0. Which is correct. Kasi, bakit? Ang theta equals 90 degrees, if you start this is 0, ang theta equals 90 degrees ay nasa initial position niya. And from that, we are assuming that it's at rest. Therefore, there's no angular velocity. Tama yung condition natin. Okay? Tama?
Yes.
So, yun. Basically, ganun siya isolve. Other questions for this problem? Questions for this problem?
None so far.
Okay, sige. Thank you.